Hi, I will briefly introduce our study on revisiting the effect of branch handling strategies on change recommendation. Change recommendation based on evolutionary coupling is one of the promising approaches to recognize overlooked changes. It takes a change history as an input. It extracts change sets from the commits stored in the change history. Then, an association rule mining is applied to generate association rules, which represent when file A is changed, another file B should also be changed, for example. After that, when the developer modified file A, the system recognizes that file B may be overlooked to modify and recommends modifying file B together with file A by using generated association rules. Here, the extraction process of change sets can be an important factor for the subsequent recommendation performance, and one of the key aspects for the extraction process is branching. In recent version control systems such as Git uses branches to record history. Some changes are directly committed on the main branch, whereas some are committed to a specific branch and their changes are merged into the main branch. Strategies of which commits are used for the extraction of change sets may impact the recommendation performance. Based on this idea, Kovalenko and his colleagues investigate the impacts of branch handling strategies for several software engineering tasks, such as change recommendation. They defined two branch handling strategies, full and first parent. In the full strategy, colored blue, all the commits, except for merging changes, are used to extract change sets. In contrast, the first parent strategy, colored red, uses commits reachable from the latest commit by tracing the first parent links, and commits on branches are excluded for preparing change sets. Here, 4 change sets are extracted in the full strategy, whereas 2 change sets are extracted in the first parent strategy. Kovalenko et al. Compared these two strategies and concluded that full strategy produced slightly better recommendation performance than the first parent strategy. We conducted a follow-up study of this because on top of this study, another possible variant of first parent branch handling strategy can be considered, like this. In contrast to the original first parent strategy that we renamed first parent without merge, colored red, the new first parent with merge strategy, colored orange, uses the merge commit to extract change sets. A merge commit includes all the changes conducted in the branch to be merged. Here, the changes for files A, B, and C are conducted in the branch are regarded as a single change set in the merged commit. This new strategy implementation looks only the first parent, but handles all the changes mostly. The difference between the full strategy and the first parent with merge strategy is whether the changes on branches are handled separately or handled at once. In this regard, we have established 2 research questions in this paper. The first one is, does the setting difference, the use of new strategy implementation, influence the recommendation performance? And the second one is, which branch characteristic affects the performance of change recommendations? What is the difference compared to the original study? First, we prepared a replication settings, which is similar to the original study by Kovalenko et al., but that compares the full and first parent without merge strategies, but we use more number of repositories and more number of evaluation criteria. In addition, we prepare another setting using the first parent with merge strategy to compare the effect of strategy implementation. So this is one of the results showing the number of repositories of which strategy outperformed the other. For example, in 15 repositories, the full strategy outperforms the first parent without merge strategy in the success rate criterion. In the comparison between the full and first parent without merge strategies, all the three evaluation criteria, the full strategy outperformed the first parent without merge strategy. However, when we use the first parent with merge strategy for comparing it with the full strategy, the performance difference between two strategies becomes rather balanced mostly compared to the comparison in the left-hand side. So the answer is yes. We conclude that the difference of strategy implementation settings with and without using the merging changes influenced the recommendation performance. In research question 2, we also investigate which branch characteristic affects the recommendation performance. We studied the length of the branches and the size of merge commit. We computed the precision of the recommendation according to the different lengths of the branches and the different size of merge commit. The result briefly shows that if we use longer branch and if we use larger merge commit, the difference of the precision becomes bigger, meaning that the full strategy becomes better than the first parent strategy. So general conclusion is that the use of full strategy treating the changes on branches separately might be better than the first parent with merge strategy that treats such changes at once from the merge commit. That's all. Thank you very much.